What's up, what's up? Welcome to Pumping Code. My name is Purya Izadi, and what if I told you that right now developers are wasting weeks in building AI agents in production, and you could actually do it in just 15 minutes. I will prove it to you here right now. I know your pain. You've built your AI agent locally, it works, it's smart, it performs, but now you want to bring it to production. This is a task of weeks because you will need container orchestration, load balancing, API gateway integration, security configs, observability, CI/CD pipelines, memory, and so much more. You just wanted to ship your agent, but now you're a DevOps engineer. What if you could skip all of that? Just from your local code to HTTPS ready endpoints. No Docker config, no infrastructure setup, no DevOps overload. Just your code, just your agent, production ready. Over the past 3 years, I helped dozens of companies across Europe, Middle East, and Africa to bring their AI solutions to production. I've seen many mistakes, and as a Udemy instructor, I help my students to learn on how to deploy their AI solutions on AWS, and I have the highest rated courses about Amazon Bedrock. Next, I want to unveil to you on how you can build your AI solutions the most effective way as of today. And the answer to it is Amazon Bedrock AgentCore. The service is generally available by AWS since October this year. It's still new and it's not too late to start working with it. It helps you to simplify your architecture and reduce your DevOps overload a lot. So it consists of 9 components. AgentCore Runtime. This is how you host your agents or MCP servers directly, and you have a choice of different types of interfaces that you will see later on. Then you have memory. Memory helps you to set up short-term or long-term memory so that your agent doesn't forget what the user is telling them. Third is gateway. This helps you to turn anything that you help into an MCP endpoint. Fourth is identity. It helps you to integrate your user pools in your identity provider of choice with an OAuth compatible endpoint directly with your agent. With that, you don't even need a gateway anymore. AgentCore Runtime or AgentCore Gateway can directly be called from your application. Fifth is observability. This one helps you to set up observability in terms of logs, metrics, and traces out of the box. This is super easy, and you can even with OpenTelemetry integrate it with your tool of choice. Sixth is browser tools. This helps you to set up browser sessions for your agent so that it can open up websites when you don't have APIs to access information. Seventh is code interpreter. This helps you to have a sandbox environment where your agent can execute code, for example, for data transformation. Eighth is evaluation. This helps you to understand the performance of your agent so that you can set up your testing pipeline. And lastly, we have policy. This is the guardrail solution where you in natural language define your rules, and with that you can control if your agent is probably having hallucinations, and the guardrails will help you to overcome these. Next, I want to show you what AgentCore Runtime consists of, and then I will show you in under 15 minutes how I bring the agent to production. AgentCore Runtime helps you to bring your own code or container and then deploy it automatically without any CI/CD pipeline that you need to create into a managed endpoint. So you can pick Python or TypeScript and then use the AgentCore toolkit to turn this with the help of AgentCore into a Docker container via CI/CD pipeline in the cloud. Or what you can also do, you can pre-package your code yourself as a Docker container. I would recommend you to go with an easier approach and just define your agent in Python or TypeScript. And then you can go ahead and use the endpoint once it's deployed. Next, we want to look at how each AgentCore runtime is built up from the ground. So the bottom layer are ARM-based Graviton instances, and these are the most performant instances to run your workloads on AWS in terms of cost effectiveness. Next layer is the session management. This is the most important layer because here micro-VM is used to make sure that you have fast cold start, because as you know, AgentCore Runtime is serverless. This means whenever you don't use AgentCore Runtime, your endpoint is turned off and then it boots up again. So you need a cold start which is super fast, and this is achieved with micro VMs. Also, you have a session isolation. With that, you can make sure that you have a dedicated AgentCore Runtime session for each user, and this makes sure that you don't have any noisy neighbor effects. And this also helps you to increase your security posture. The next thing is each session can run up to 8 hours. This is super important because your agent runtime workloads might want to run longer, and this is a typical case with agents, and with that you can achieve that easily. And also within this 8-hour window you can have idle time, and whenever your runtime endpoint is idle, you're not being priced by, so this is super powerful. The next layers are Linux distribution running on these micro VMs and a Docker image. Whenever you build your own Docker image for AgentCore Runtime, just make sure to keep that Linux distribution part also in mind. Other than that, I would recommend just go ahead, use your code as TypeScript or Python, and then AWS will make sure to build a Docker image for you. Next, I'm going to show you what the entry doors are of your AgentCore Runtime. So for AgentCore Runtime, you can pick an HTTPS endpoint on port 8080. With that, you can use a typical REST API to connect to your AgentCore Runtime. If you want to use WebSocket, and this is necessary if you want to have, for example, a streaming session, you can use that as well on the same port. By the way, the HTTPS endpoint supports asynchronous and synchronous workloads, so if you want to have the streaming behavior just with HTTPS, you can use that as well. WebSocket helps you on top if you want to have a server-client and client-server communication, which is bidirectional. This is truly useful if you want to have, for example, voice agents. The next two entry points are MCP and A2A. MCP became super powerful throughout this year in simplifying how we create and share tools for agents. This is a common interface which you can use to import either tools from others and third parties, or to make your own tools MCP compliant. And if you want to host it directly on AgentCore Runtime, you can do that. By the way, you can also wrap up agents themselves as an MCP endpoint. This is also possible, for example, if you think of building multi-agentic solutions. On top of that, you can also use the agent-to-agent protocol, which is also abbreviated as A2A. If you want to host the A2A agent on runtime, you can do that as well. And for that, you can use the port 9000. If you want to learn more about AgentCore and dive deeper into all components, I definitely recommend you to check out my Udemy course about it, which is 4 hours long, and it has hands-on examples about each component. This course is also the highest rated course about Amazon Bedrock AgentCore on Udemy. And now back to building the agent in just 15 minutes. So now it's showtime. I want to show you how you can build your own agent inside AgentCore, bring it to production in just under 15 minutes. I have my timer ready here, and now we will press play, and now the time is running. Let's go. Alright, so what you can see here is I'm now in the AWS console, and here you can also see the different components that are available within AgentCore. So we have the runtime, gateway, memory, and so on. And today we focus just on the runtime. So I click here on runtime, and you can see I've already 2 AgentCore runtimes ready here. I have here more complex travel companion agents. If you want to build them, you will also see that in the dedicated course I have built for it. But now we want to build a simple agent, and we want to build everything live. So now what we want to do is we want to go over in our coding environment, and I'm using Kiro as my IDE. So now I open up Kiro, and now what you can see here is my Kiro environment. And I've cloned a repository which contains all the code examples out of my course, and you can access that one for free on GitHub. And you find the link in the descriptions. Now what I want you to do is, if you want to replicate that, just go ahead and open up the second notebook, which is called Runtime Setup. Now I will scroll up here so we can start this one from scratch. And now one thing is you need to configure your AWS credentials. I've already done that, so I run the first cell over here. Once this is done, I have my AWS credentials ready loaded, and now I can connect to the AWS APIs in my notebook over here. Everything you see here is Python code running in a Jupyter notebook. The next thing is I want to run a few imports to bring in the components necessary. So we want to use AgentCore Runtime, and we also want to use the Strands SDK. Strands SDK is an agentic framework which you can use, comparable to LangGraph, CrewAI, and so on. And this one is the easiest way to build your agents directly on AWS. All right, so let's run this one as well. Good. And the next thing is we first want to create the agent locally, test it, and then see if everything is okay. And then we will package it up and put it into AgentCore Runtime. So what you can see here is I'm now defining tools for my agent, and I'm using the syntax of Strands SDK. So whenever I have this tool annotation, I can define a tool. So our agent will have a few tools, and this agent we are building will be a travel companion. So it has a tool to understand the travel preferences of the user, and it's hard-coded here. So what we see here, we're storing in this tool the information that the user has a hotel type preference of a mid-range price, food preferences are vegetarian, and the budget range is moderate. We also have a helper tool to calculate the budget. what we define here is how we want to distribute the budget that we have in terms of different categories. So for example, 24% should be allocated for the flights, or for example, 36% should be allocated for the hotels, and so on. The third tool is containing several informations about specific destinations. So for example, what are the attractions in Rome that we want to specify inside our agent? So it's, for example, the Colosseum, the Vatican, the Trevi Fountain. We have the same also for Florence and Venice. So these are the three tools. So let me run this cell over here. So with that, we can define now our tools for the agent. The next thing is we want now to define which LLM we want to use and also the system prompt for our agent. As an LLM, we are using the Claude Haiku 4.5. Now, what we are doing here is we are using a Bedrock model. Amazon Bedrock itself is a serverless service which helps you to easily connect to large language models as an on-demand usage, so that you don't actually need to host virtual machines hosting these large models. Everything can be called directly just via an API by calling Bedrock. Now, as you can see here, we have a model ID specified. If you want to find out how the model ID looks for the model that you want to use, or if you want to replace this one, to do that, just go into the AWS console and then type in here Bedrock, and then you can go ahead and look into the model catalog. So as you can see here, once this is loaded, there are tons of different models. Here, for example, we can see also the Mistral models, or for example, the Claude Opus 4.5 and others. And then just click on the model. And then if you scroll down, you will find the model ID. There is also a caveat to this. There are global endpoints, which are called cross-region inference endpoints. And this helps you to improve the performance of your model calls. So this is something I'm using here in the example. And if you want to explore these endpoints, just go over here to cross-region inference. And for example, type in Claude Haiku. And now you can see we have two options. So for example, I want to use the US endpoint, so I just click here. And then what you can do is you can copy the inference profile ID. So this is what I selected in this example. With that, you can also switch to other cross-region inference endpoints and select the model of your choice, or you just go with a single region and then copy the model ID from the model catalog over here. All right. So with that, we have specified the model, and next we are also defining a system prompt. So we are telling the agent that it's a travel companion specializing on trips to Italy. And we also define the expertise that the model has in terms of flight and hotel recommendations, budget optimization, and so on. And then what we do is we define a Strands agent over here, and it has the model assigned to it, the tools that we created, and the system prompt. All right, so now we run this one, and next we want now to test out the agent. So we just scroll down, run the cell over here. Now what you can see is we're asking, we want to plan a trip to Italy, and here we can already see the response. So it's super fast. So the call to Claude Haiku on Bedrock is also really blazing fast, as this is a smaller model. And yeah, and you can see the response. So the agent is also probing like, hey, how long you want to stay? What is the total budget that you have? Which destinations in Italy you want to visit, and so on. Now, what we can do is we can also tell it the budget and that it's a 10-day trip. So let's see how it would now allocate the distribution. And as you remember, we had also this tool use, which helps us with the breakdown. And it's now also using that. You can, for example, see here the budget breakdown. All right, so our agent is now ready. And now what we want to do is we want to package this orchestration logic and bring it into AgentCore Runtime, so that then AgentCore Runtime is calling the Bedrock LLM and everything is running in a managed production-ready environment. So let's go on. So next we want now to deploy the agent to runtime. So what you can see here is the same code that we had for the Strands agent. Now we're just adding a few lines to make it AgentCore Runtime ready. So first we import the Bedrock AgentCore app, and we are also initializing it over here. The tool definition is still the same, so I will skip it over here. Also, the agent definition is still the same. Now, one thing that changes is the annotation with app entry point. So this is specific to AgentCore Runtime. So you need to make sure to add this one. And also how we package the payload. So this is how the data is passed over into the AgentCore environment. And what we do is we receive a payload as an input, and here we can pass out the prompt, which is coming from the user calling the agent. And now we can hand over this prompt coming into AgentCore Runtime and send it over to our agent, which is a Strands SDK agent. That's basically it. So once we define this app entry point to map the input of the payload towards the prompt that goes into the Strands SDK agent, that's it. So nothing more necessary. And now you can see how simple it is actually to turn your Python code, which is orchestrating your agent, into something that AgentCore Runtime can run as a managed environment, also running completely on a Docker container. So let's run this one. I'm also locally storing this one over here under travel agent py. So you can also find it here inside the folders under simple agent. You can see the travel agent py. We also create a requirements.txt file. So this defines which Python packages our agent needs to load so that it has all the imports necessary. So just run this next cell. All right, and now we're actually ready to configure the AgentCore Runtime. So this is the first step. With that, what happens is the AgentCore toolkit creates a Docker file describing all the things necessary for this project as a Docker bootup file, and also creates a metadata file for AgentCore Runtime itself so that it knows your account number and some additional specifications. So what we do is we also define where our agent Python file is stored and where the requirements.txt is stored. Good, so let's run this cell. So this one is successfully completed. And now what you can see, few files have been added to my directory over here. So a Docker file, a Docker ignore, and a YAML file, which contains all the metadata for AgentCore Runtime so that it can deploy your agent for you. All right, the next thing is we will run an AgentCore launch, and this one will now spin up a code build pipeline on AWS, create the Docker image, store it inside ECR, which is the Docker registry inside AWS, and then create the AgentCore Runtime endpoint. So let's run this one. As you can see in the comments, it might take up to 5 or 10 minutes. For me, typically this is quite fast. So I will let it run here in real time for you so that you can also see how long it takes until everything is deployed into the endpoint. By the way, we can also have a look on our timer. So we're now around 12 minutes and we built everything from scratch. So not bad, huh? So AgentCore is almost done. And here we go. Looks like we're done. Check mark is here. So the endpoint is ready. And now what I will do is I will just put this timer out of the view for a second. This is just an additional check that the endpoint is ready, which is the case. And now what we can do is we can prompt, for example, a 10-day itinerary with a $5,000 budget against the agent. And now nothing is running locally anymore. This is completely hosted on AgentCore Runtime, and all the logic now is running in there, and then it's also calling the Bedrock LLM. So everything now runs inside the AWS cloud. Answer is here, and now I show you the timer. Even under 40 minutes, I now click on stop. So you see it was super simple. We even took the time to traverse through the AWS console, and everything is now ready to use under 15 minutes. Good. Now what you can see is if you follow this notebook, you can also do additional things. You can send more prompts towards your agent. And this session has also consistency. So if you ask multiple questions against the agents, like you can see over here, first you say, hey, I want to visit to Italy. Then this is my preferences in terms of how much I want to spend for hotels. And then you ask it, hey, tell me more about Rome's attractions and so on. It will memorize everything you told it within that session. So here you can also see how powerful this session isolation of AgentCore Runtime is. So with that being said, just go ahead, clone the repository, and definitely make sure to try it out. I hope you liked this video. and got a good first glimpse into AgentCore Runtime, you find all the information mentioned throughout the video in the description. And also, if you want to stay in touch about the latest AWS news in a written format, I have also a newsletter called Pumping Code Newsletter. And as well, I have a weekly podcast with my co-host Tillman, who is a sales lead in the software vendor industry working with cloud technology and AI. And we are talking about the intersection of personal development and AI and how our experiences in solving customer problems, improving ourselves, but also upskilling continuously on AI and building our own products. Now, with that being said, I really hope you liked this video and could learn new things about AgentCore. And there will be always weekly challenges also inside the Extra Mile podcast, and this was one of them. From now on, I will also continuously publish new videos about AI on AWS on this Pumping Code channel. So with that being said, I wish you a wonderful day ahead and see you in the next one when it's about building AI solutions on AWS. Have a good one.